Right, for a quick overview of trig substitution, I really recommend this page, 17Calculus.com, integration techniques. So this is linked on our other site. First, to understand that trigonometric substitution is done in a question where there's no trig function staring back at you, most likely. But what you're going to do is use a substitution that will introduce a trig expression that you can integrate. So the magic that's going to happen here is that you are going to turn two terms into one term, but those two terms cannot be added up together, they cannot be simplified. And the trick is using these trig identities. So if we have an expression like this, somewhere, say in the denominator of a fraction that we're trying to integrate, then you can say, well, I know that something squared plus 1, suppose that constant was 1. If I have something squared plus 1, and the something was tan theta, then I could use this identity to turn these two terms into a single term. That is the game we're playing here. If I wanted to use this lovely identity, sine squared theta plus cos squared theta equals 1, that would be happening where one of these gets thrown to the other side, and you have something that's of the form of 1 minus something squared. But here we can have it as any constant minus something squared. If I had the substitution that something squared was so that I could take out a factor of a squared, land up with a 1, I would be able to then take two terms and make them into one using this identity, and so on. So there's three basic forms using, in fact, just two trig identities, this tan one, tan sec one, in two different ways. So if you are good friends with these trig identities, you are going to be finding this method not so hard after all. And then they talk about, okay, you can browse these videos if you like. I think they're pretty good. And here they give you a rule. If you want to memorize these, go ahead. I never do, because that a squared could be anything. I think about trying to create, if it's got a plus like this, I'm trying to create a 1 plus tan squared theta over here. So I want my x squared, when I've made a substitution, I want this term to be a squared tan squared theta, so that the a squared comes out as a common factor, gives me a tan squared theta plus 1 all times a squared. A squared is just a constant, I can fiddle it, but the tan squared theta plus 1 is just sec squared theta, and that's going to reduce two terms into one term. Why do I focus so much on making two terms into one term? It's because if you have two terms under a square root sign, you're sunk. You can't simplify it. If you have two terms under a fraction sign, you can't break the fraction. So this is just a technique to try and give me a bit more movement in my question so I can manipulate further and try and break the integration. So this is quite a handy table too. Again, if you want to memorize, then go for this one. But this is also teaching you that if you can get your expression, your two terms, one of them is a constant, one of them involves your variable, and you can identify the function squared in the one part, and you've got a constant squared in the other part. Choose your substitution not to be u equals something about f of x, but f of x, that thing in your question, equals the constant that appears over here, tan of that angle, or sine or sec, depending on where you got pluses and minuses. So why am I doing that? What's happening here is that theta is the new variable. That's going to be like my u. If you like, you could have tan u. That's the new variable. So it's a different way of writing your substitution. Instead of u equals something, I've got something equals something about u. And how am I going to get my du dx bit from here? Implicit differentiation. Okay, so here are some examples for you to spot if you can identify what would make a good substitution. If I see something like this in the question, I'm thinking, plus a constant, that could be like plus 1. Something squared plus 1 could be using the identity tan squared theta plus 1, or tan squared something. So I would like this thing here to first be able to give me a constant that will be able to be common factored out with that 9, and then to be of the form of tan squared theta. So I look at this whole thing here, I say that is the same as e to the x all squared. So e to the x is my function part, and if I let that function equal square root of this one, which is 3, times tan of theta, then what I would be getting here is if I squared both sides of this, I get e to the 2x. So there it is, e to the 2x. What would that equal? The square of this, which would be 9 tan squared theta. The 9's come out as a common factor, and what you're left with is a trig identity, tan squared theta plus 1, which you can then write as sec squared theta. That's where we're going. And here I notice the x term has got a negative. There's the 1, so this is like 1 minus x squared, or 1 minus something squared. Think of the trig identity, 1 minus sine squared theta. Could say 1 minus cos squared theta, both work. So if I was thinking that, I would say I would like this whole thing here to be something like sine theta all squared. But I've got to compensate for that 16, so because it's going to all be squared, that thing that goes here would be 4 sine theta. So that when I square it, I get 16 sine squared theta. Take out 16 as a common factor, and there's my 1 minus sine squared theta. And then something like this again, you would need to have that 2x, square root of this part, equal to something that's going to cancel the 25 when I get it out. So that would be 2x equals 5, and then what is the right trig expression? This is something squared minus a 1. So that's using the tan and sec identity, but the other way around. So you would like 2x to equal 5 sec theta, so that when you square this side, there it is squared, you'd get 25 sec squared theta. 25 comes out as a common factor. Sec squared theta minus 1 is tan squared theta. 2 terms go to 1 term. So that's really the beginning game. That's how you need to train your eye so that you can see what would make a good substitution. So over here I'm seeing constant minus variable squared. I'm thinking, what identity uses that? 1 minus something squared? 1 minus sine squared theta. So I would like 3x to equal 9 sine theta, so that when I squared it, I'd get that 81 coming out as a common factor. And then you can check out the answer. There's videos and solutions. Sometimes these solutions are written, sometimes they're videos. And if you want a quicker way, if it's a video and you just want the answer, you can copy and paste this into Symbolab or wolframalpha.com. Symbolab's probably a bit better, because show you some steps for how to calculate this. Beware, there are sometimes different ways of solving these problems. If you don't like the one way it's solved, there are other options. You can always ask me.